Hello friends, welcome back, and today we are going to discuss about this calculation of the operating direction for different makes of numerical relays. In continuation with our series on overcurrent and earth fault relaying, we have already discussed all the theoretical concepts related to the overcurrent protections. In the preceding sections, we have discussed in details about the concepts of overcurrent and earthfall protections, the IDMT characteristics, coordination of directional and non-directional relays, then the concept of polarization quantities, RCA, ROA, etc. So all these things we have already discussed, and in this particular sections, we are going to discuss about how to calculate the operating region or how to determine the operating region for ABB make and Siemens make numerical relays. In the upcoming sessions, we will discuss the same thing, the same concept or similar concept for the GE, MICOM or NR relays. So without wasting any time, let us start with today's session. And I hope the concept that we have discussed in the last session regarding the RCA and ROA are clear to all of you so that we can just build upon that concept for the today's session. And if you see now, the first relay that we are going to discuss is the RET-REL relay, which is from ABB. And in this relay, if you see here, the uh, in the last session, we have discussed that in order to determine the operating region for any directional overcurrent relay, there are two things. One thing is called polarization quantities, because you cannot determine the direction of an AC quantities independently, because it will keep changing in every half cycle. For a 50 hertz system, it will keep changing in every 10 milliseconds. So in order to determine whether the current is in positive direction or in the negative direction, you need one reference phasor, and that reference phasor is called polarization voltage or polarization quantities. Uh, Now, different manufacturers use different methods to determine this polarization voltage. Uh, when During the days of electromechanical relay, that polarization voltage was determined by the 90-degree connection. That means for A phase or for R phase fault, the polarization voltage by default was VBC. But in the numerical relays, it is the choice of the user or the choice of the manufacturer, basically, that they can determine the polarization voltage by different methods. They can in some relay you have the options to set how you can determine the polarization voltage. In most of the relay it is by default the internal thing. So now if you see this page, this is from the technical reference manual of ABB relay. And here, if you see, for a phase-to-phase fault, this relay says that the reference voltage is basically the uh, phase voltages between the two phases which are involved in the fault. For example, for RY fault, the reference voltage is VRY. For YB fault, the reference voltage is VYB. For BR fault, the reference voltage is VBR. Similarly, for the Rn fault, the reference voltage is Vr. Yn fault, the reference voltage is Vy, like that. And then the direction, the current that we are taking, that the fault current is the same, IL1, IL2, IL3, or IL1 minus IL2. And then we have to draw this V reference and the I direction in reference to V reference. Where is your I direction? At what angle? That is called RCA. And if you see in this relay, this basically it is saying that this RCA, whatever it is given in your setting, it is to be drawn lagging. Our general understanding is that lagging, if we are drawing, that means it is minus or minus something, suppose minus 30 degree, minus 40 degree, minus 60 degree. But if you could recall from our previous session, we have already discussed that RCA, we can, it is only the terminology that we can say that it is leading or lagging depending upon which voltage we are checking. For example, if you see here, for the A phase fault, now if this is a 45 degree RCA, you can also say that this 45 is In reference to VA, it is lagging. So in reference to VA, this 45, we can say that minus 45. But in reference to VBC, we can say that this is leading, or that is plus 45 degree. So depending upon which voltage we are taking as the reference voltage or as the polarization voltage, this RCA angle can be negative or positive. So if you see now in ABB relay, because they are taking this reference voltage as the same phase voltage, so the RCA angle, whatever it is given in the setting, it is always to be drawn lagging. So now if you see, this is then there is one more thing. This is RCA, and ROA by default, if you recall again from the last session, I have said that now you have drawn the RCA, so the operating direction will be plus minus 90 degree in this side. But for numerical relays, generally it is very accurate. They can give you the exact some tolerances or some relay you have the settable parameters like ROA, the operating angle. In some relay, it is by default the internal things. For example, for this ABB relay, this is settable. So now if you see this setting, this is one example only. So the angle RCA is given here 55, angle ROA it is given 80. Now if you just see here, angle RCA it is given 55, but 55, if our general understanding is 55, that means it should be in the anti-clockwise direction. But since the ABB relay is using the reference voltage as the same phase voltage, so that means your RCA is to be drawn lagging, and that's why if you see here, RCA is always drawn lagging. Now uh, the other settings which are important here are this characteristic, which characteristic we are selecting, that is normal inverse, or very inverse or extremely inverse like that. Then the operating direction is forward. I1 greater than is basically the pickup current, 1.5 ampere secondary, and then K1 is the TMS. So these settings depends upon the calculations of the utilities and the other parameters like source impedance, line impedance, and other things. So we are not going into the details of how to calculate this TMS or to calculate the pickup settings. We are just saying that this is the setting of one of the utilities, and we have to determine the operating angle or operating region. Now, another important thing is start phase selection. One out of three means in case the fault is in R phase or Y phase or B phase, your phase selection should start. Now, this is an example. We are having an angle of RCA as 65, angle of ROA as 80 degree, and we have to determine the operating region for R phase fault, for Y phase fault, and for B phase fault. Now, first of all, just draw the three phase voltages. So this is my R phase voltage. Y phase, I know that it will be 120 degree lagging, and B phase it is 120 degree lagging the Y phase. Now, if I have to draw the operating region for R phase fault, we know that for R phase fault, in this relay, the reference voltage is R phase itself. If you see here, the for R phase, the reference voltage is it is itself, and the current is IL1. So first, we have to draw for R phase. This is my reference also. Then the next thing is for R phase, we have to now draw the F, and IF is to be drawn at RCA angle, and that RCA angle is 65 degree, and this 65 degree should be lagging. So this is my IR, or I can say it as I direction in terms of this relay, or we can say it IF. So this is 65 degree. Then comes the operating region. So operating region is if nothing is given, it should be plus minus 90 degree from here. But now in this relay, it is given the ROA, that is 80 degree. So you just draw 80 degree from here. So this is 80 from here, and also from here you have to draw 80 degree. So you can just draw like this 80 degree. The total angle, now if you see, this angle up from here to here is 65, and from here to here it is 80. That means from here to here, that is from R phase, this angle is 15 degree, this angle. Similarly, in this side, this angle is 65 and this angle is 80. So total angle from here to here is 145 degree. And this side is our operating region. Now let us draw it again in simple terms. This is my VR or V reference, and the operating region is this 15 degree to this 145 degree. This is my operating region. Now you can call that this 15 degree is from here to here. That is, it is in the anti-clockwise direction. Anti-clockwise direction 15 degree. Anti-clockwise we already know is positive. That means plus 15 degree. But this 145 from here to here is in the clockwise direction 145. So we can say this is minus 145 degree. So your operating region for R phase will be plus 15 to minus 145 including 0. So for R phase it will be 15 to minus 145 degree, or we can also write minus 145 as 145 plus 360, that is 215 degree. So we can write it as 215 to 15 degree. So this is my operating region for R phase fault. Now, if you want to determine the operating region for Y phase fault, the simplest method is you can directly subtract 120 degree from both, because you know that the Y phase will be 120 degree lagging. So 15 minus 120 to minus 145 minus 120. And now you can say that this is minus 105 to minus 265 degree with minus 120 inclusive. Why minus 120? Because it is for Y phase, so minus 120 it will automatically come. You can also write minus 265 as minus 265 as minus 265 plus 360, that is plus 95 degree, and minus 105 as minus 105 plus 360, that is 255 degrees. So you can see here 95 to 255. So this is Y phase operating region. Now if you want to determine the operating region for B phase, it is again same thing. You have the reference for the R phase, and we know that B phase will be 240 degree lagging of R phase. So we can write 15 minus 240, then minus 145 minus 245, and you can say this is minus 225 degree and minus 285. Minus 285 you can also write as 360. So this is 75, and this is minus 225 degree. So for B phase it will be 75, 240 minus 225, or you can also write minus 225 as you can write minus 225 as this is not minus 285, this is minus 385 plus 365, that is minus 25. So this is minus 225, 240 minus 25, or you can write it as, if you write plus 360 here, it will be 135, 240 minus 25, like. So this is the method to determine the operating range for R phase, Y phase, and B phase faults. Now the next relay which comes into the picture is 7SJ60 or 66 or 7SJ80, which is from Siemens. And now if you see in the Siemens relay, it is again the page is from the Siemens relay manual. This relay very clearly says that it is using a quadrature connection. That means for A phase fault, it will be using VBC, for B phase, VCA, for C phase, VAB. And you can see here for A phase, it is using the voltage VBC, B phase, VCA, C phase, VAB. Similarly, for AB, BC, CA, and ABC fault, and the current will be for A phase, B phase, C phase is their own fault current. Then in this relay, there is no settings like RCA and ROA. Internally, this relay says that their ROA is plus minus 86 degree. Like in the ABV relay, we can set ROA or 90 degree or 85 degree or 80 degree. Siemens relay, it is fixed 86 degree. So that is, you have to draw wherever our RCA comes, we have to draw plus 86 or minus 86 from that. Then the next thing is, if this relay doesn't have RCA, then from where RCA comes? In this relay, the settings RCA comes from this setting phi rotation. That's phi rotation is the angle of rotation. This angle of rotation is basically the same as RCA, and this angle of rotation in this relay it is at setting 1519, and this angle of rotation is basically the rotation angle of the fault current from the reference voltage in the anti-clockwise direction. Why anti-clockwise direction? Again, because anti-clockwise direction is our y2 direction, and we have already discussed that this relay is using reference voltage as VBC. For example, for R phase fault, it will be using YB. For Y phase VBR. So if you see here, this is VSCA, that is the short circuit voltage of A phase, ISCA, short circuit current of A phase, and this is your angle between these two. And then wherever my ISC comes, it doesn't matter because we have the reference VBC for A phase fault, and then the angle of rotation, that is RCA again, is this, and this is my maximum sensitivity line, and from here I have drawn plus minus 86 degree. So this is my forward region of operation. So now in this relay, if you see, this is the operating direction, and this is rotation angle reference for the voltage, and this rotation angle reference itself is the RCA. So now if you see the difference between the Siemens relay and ABB relay, if you are setting in both relay 60 degree 60 degree, the Siemens relay 60 degree means it is 60 from the reference voltage VBC, or you can say that 60, if this is my VR, then this is my VYB. So this is 60 from VYB. So this is 60 from here. That means from R it is only 30-degree lagging. While in this ABB relay, if you set RCA as 60, it will be directly from R, it is 60-degree lagging. So now if you want both, if you have both these relay, Siemens relay and ABB relay in your system, for the backup protections, and you are using both as backup protection for main 1, main 2, and if you want to have the same operating region, then you have to select RCA in one as 30 and one as 60, then only it will match, because both are using different terminologies. Now, how to determine the operating direction? Again, it is very simple things. I have this rotation angle here 60 degree. I want to determine the operating region for R phase fault. First of all, we simply draw this VR. This is my VY, and this is my VB. So the reference voltage will be VYB, and the angle of rotation is 60 degree from here. So this is 60 degree, and this 60 degree is angle of rotation, that is phi rotation, or RCA. This is 60 degree. So this angle is 60 degree. Now internally I know that in this relay it is plus minus 86. So I will draw from here 86 degree, which is this, and from here minus 86, which is somewhere like this. So now this is my total operating region, forward region, like this. From here to here is the forward region. So this angle is 60 degree, and from here to here this angle is your 86 degree. So how much is this angle? This angle will be, uh, if you see here, uh, this angle 60, and from here to here it is only 30, and from here to here it is 86. So this angle should be 56 degree. Now this angle is 30, and from here to here is 86 again. So total will be from here to here is 30 plus 86, that is 116 degree. And this is the anti-clockwise, this is clockwise, so we can write 56 0 1 1 6. This 116 is minus, so you can write 56 to 244 degree. So this is what it is coming for R phase fault. Now this is coming when we are taking the we are calculating in terms of R phase. But if you calculate in terms of this, so then your angle will be different thing, because if you are calculating with reference to 90 degree with reference to YB, so this is my 60 degree, and then from here to here it is 86 degree. So from here if you calculate, this angle will be somewhat different. So it is all about nomenclature, what nomenclature we are using. But for this particular case, if you see here, for the same settings, now a user, if he is assuming that if I am setting 60° in the Siemens relay and 60° in the ABB relay, the operating region will come exactly the same. Then it is not same because of the different nomenclature that these relays are using. So now this you have the R phase operating region. You have to determine for Y phase. Simply just subtract minus 120, 56 minus 120, and minus 116 minus 120. You can write this as minus 64. This is at minus 236°, including minus 120. So this minus 64 you can write as minus 64 plus 360, and this minus 236 you can write as this, and this will be then 296, and this is 124 degrees. So this is again 124 to 296. Likewise, you can determine the direction for B phase. So I hope the concept that we have discussed in this session is clear to all of you. And now you can see that we are assuming that if we are setting 60° in Siemens relay and 60° in APV relay, then both relays would operate at the same angle. But that is not so, because both relay are using different algorithm, both relay are using different methods to determine the operating region. So even if your settings are same, the operating region are going to be different because of the different nomenclatures they are using. Uh, we will keep this session only up to this. In the next session, we will discuss about the algorithm that auto determine the operating region for NR relay, MICOM relay, and then D60 relays. So hopefully the concepts discussed in today's sessions are clear to all of you. So we will meet again in our next session. Till then, thank you and goodbye.